is Dr. Marta Russo. She's going to talk about manipulating a whip, motor control beyond reach. She's a postdoc at Northeastern University in the Action Lab working with Dagmar Sternar. So without further ado, I'll let you take over, Marta.
Okay, let me share my screen, and thank you for the introduction. I hope you all see my screen correctly. And today I'm going to talk to you about a task, and I hope that I will interest you with a very exotic task, which is manipulating a whip. And a lot of credit of this project needs to be given to Alexei Krotov, who actually graduated with this project for his master in the Action Lab. So the rationale for this study is twofold. And we wanted to investigate, the first reason is that we wanted to investigate complex dexterity in humans. Because in motor control, a lot of study focused on reaching or catching and throwing, which are all tasks that, although require a lot of coordination, at the same time are not reflecting this broad spectrum of human dexterity. And in particular, what we wanted to investigate is human dexterity with flexible objects. Because in our daily life, we deal with the flexible and under-actuated objects. And that's what we wanted to investigate more in this study. On the other hand, in our daily life, we intertwine different actions that can belong to the discrete or the rhythmic framework. A discrete action could be a throw or a catch or even a reaching movement. And during our daily life, we're actually performing a lot of rhythmic actions, so like walking or running. And we believe that we need to investigate tasks that can put together these two frameworks and have a comprehensive theory that can investigate both kind of actions in our motor control. And in order to do that, we decided to ask participants to manipulate a bullwhip, which is indeed an under-actuated flexible object of a high complexity, as it has hundreds of degrees of freedom. However, humans can actually use this object, and as you can see in the video here, we can use it with a very high precision, as April is doing, like playing Jenga. And taking inspiration from this task, we asked participants to hit a target with a whip. And to ask our second question, we asked participants to perform the task in a discrete and a rhythmic fashion, where discrete is a task, an attempt to hit the target with pauses in between different attempts, while rhythmic is a continuous set of actions, one after the other. So in particular, during the task, we collected the kinematics of the arm and the whip, and 16 participants were recruited and performed 5 blocks in each fashion, discrete and rhythmic. The task was set to be, the setup was set to be in order to have a 5 centimeters overlap between the tip of the whip and the target, which means that in order to hit the target, participants had to have the arm and the whip both extended in order to have a successful trial. We measure participants' performance by measuring the number of times they actually hit the target during the task, and we call that the success rate. And we also evaluate their performance by measuring the error, which is actually the minimal distance between the tip of the whip and the target. And as you can see in this figure, there is a larger inter-individual differences in the performance. But however, the discrete rhythmic performance also show a difference. And indeed, if we put together this result by pulling together the results of Discrete and Rhythmic and all subjects together, you may notice that participants achieved a better performance in Discrete than in Rhythmic. And this was confirmed by the success rate that was higher in Discrete and the error that was lower, together with its own variability. And these results were confirmed in all blocks. So all the 5 blocks and all the 3 metrics. Then we asked, what was different between these 2 styles? So what were the participants doing that led to such a different performance? And first of all, we wanted to investigate the hand kinematics. So we noticed that due to the complexity of the object, that also the arm and the hand were moving in a simple fashion, but they had different phases during the motion. In particular, participants set the throw before actually attempting to hit the target, and then they actually threw the whip until they actually unfolded the arm and the whip in order to reach for the target. We wanted to look for these phases into the hand speed profile, and we define the first phase of the motion between the preparation onset and the throwing onset, defining the preparation phase, which is the first peak that you can see in this velocity profile. And after that, we defined the throwing phase as the second peak of the bell speed profile that was ending at the time at which the whip reached the minimal distance from the target. And I'm referring to these 2 peaks in the speed profile as this was a characteristic that many subjects had during the task. And this is what I'm going to show you here, where you can see the velocity profiles for all subjects from 1 to 16 in the circle around, and the 2 colors indicate the 2 different styles, Discrete and Rhythmic. You may notice that all participants had these 2 peaks in their speed profile, and that's also confirmed in the average that you can see here in the center panel. What we also noticed, however, putting on this trial together, is that while the throwing phase was very similar between styles and between subjects, which is the second phase here, actually the first phase, which is the preparatory phase, was longer in Discrete. And this was confirmed by the statistical analysis, and you may see that indeed Discrete had a longer preparation phase as here in this inset. We believe that this affected participants' performance, and we believe that having more time to set the whip before the throw could actually help participants to reach a better performance, to achieve a better performance. But then we also asked how the whip needed to behave in order to reach the target, and what were the key features of the whip during the task. In particular, we realized that the whip during its motion was moving and sometimes was entangled, but then it could unfold close to the target and actually hit the target. And that was that required a good timing, because then the whip can keep moving as in a follow through, and then be more entangled. And this was an example of a successful trial. But in a non-successful trial, the whip could unfold and still be quite entangled while it's close to the target, and then unfold when it's too late to actually reach the target, which means that this will lead to a less successful performance. We wanted to then identify these 2 time instances in the whip motion, and particularly defining these 2 states of the whip, which is the time instance of the maximum whip extension and the time instance of the minimal distance from the target. So we wanted to define these 2 time, and we wanted to compute the difference between these 2 time in order to understand if participants were timing the unfolding of the whip correctly in order to reach the target. And as you may expect, when we compute this time difference, we realized that in Discrete, this difference was smaller than in Rhythmic, suggesting that participants were timing the whip extension closer to the time of the minimal distance from the target, which led to a better performance. In conclusion, I showed you that in manipulating a bullwhip, there was a large inter-individual variability in the performance, but however, all the participants achieved a better performance in the discrete style. We ascribe this result to the fact that participants used a longer preparation in discrete, and they were able to time better the whip extension in the discrete style. I haven't told you that there were some other interesting features in Rhythmic, which also are very interesting, and in particular the fact that participants improved their performance in Rhythmic that we didn't see in Discrete, and that actually the unfolding of the whip was smoother in the Rhythmic style, and this was presented by Alexei yesterday here at Neuromatch. So what is the take-home message from this for preliminary analysis? Well, is that we believe that timing is a key factor in throwing a whip, shown both by the preparation phase duration and the time of the whip unfolding. But we still want to investigate further what are the kinematic features of the hand and the initial conditions of the whip that are necessary to have a successful hit. And we want to further investigate actually what are the control strategies that are engaged in the two styles and that they lead to such different control strategies. With this, I thank you all. I thank all my lab, my PI, Dagmar Sternad, and in particular, Alexei Krodov, who actually collected and analyzed this data. So with this, I thank you, the Neuromatch organizer, and I'm here for the questions.
So I'm going to applaud on behalf of all the viewers. We have a few questions for you, so let's get into that. The first question is from Andrea, and she asks, how did you track the whip kinematics?
So, well, that's a good point because it's a complex object that requires complex tracking. So we tested different approaches, but at the end, in the end, we developed customized markers that were soft markers, and we sewed basically the marker onto the whip, and they were small sponges covered with reflected tape. And that was the best in terms of accuracy that we could achieve with a motion capture system.
Cool. The next question is from JJ Orban, and his question is, were there different phases in the learning? Example, exploration, learning, and then consolidation?
So we ask the participants, first, when the participants come in, we show them, so the experimenter played with the whip and let the participant play with the whip for a few minutes. And then there were the 5 blocks for each style. So basically each participant performed 10 blocks. So I would say that was maybe a little exploration, but everything was happening during the session. We definitely wanted to investigate also what happens if the participant is given more time, or maybe is coming back another day and keep playing with the whip. One thing that I might say here is that all the participants were basically naive. No one is an expert, but few of them had some little experience with the whip just by random happening. And we saw that they achieved a better performance, but we couldn't find, so far at least, any difference between participants.
Cool. The next question is from Julia Aldemir. And the question is, really cool talk. I would assume that having shorter prep in Rhythmic would also be facilitating. You say it helped them prepare, but rhythm is such a repetitive fashion that they wouldn't need to have a second thought about it, even though they spend time to calculate the distance extension. I would think it would be for once. Okay, the question is long. You said they showed improvement in rhythmic, so the repetitiveness is the case that actually facilitates, I guess. So actually, didn't you say that they, okay, yeah. So
So
I think the question is, did the repetitiveness of the rhythmic task help in the learning?
it could be. We were kind of surprised that we saw improvement in rhythmic, but they didn't manage to achieve the same performance as in discrete. So I think that the fact they were repeating the motion in the same block, so one trial after the other, helped in improving, but at the same time constrained participants in that loop of repetition. So maybe it didn't have to explore enough the solution manifold, so they couldn't actually improve enough. But again, we should have more sessions to actually say that.
Okay, let's take one more question before we move on to the next talk. Maybe we can have like a short Q&A at the end of the session as well.
I can also reply in the chat if it's necessary.
Yeah. Do I understand correctly that in the rhythmic task, the trials were connected so that the trials are not independent of each other? So it's
Yes.
like all one movement.
So the recording was in one block during the rhythmic session. All the trial were happening without a break, so one after the other. And so we actually decided to parse the trial in the rhythmic in order to compare it with the discrete. But we are also going to investigate the whole session all at once, because indeed there was a whole motion, a continuous motion. That's also why we wanted to investigate this rhythmic fashion. So yeah, I think the answer is yes.
Great. So I'm going to leave the remaining 3 questions for later. And in the interest of time, let's move on to the next speaker. Our next speaker is